is and the results of the research. We do that through sampling and selection. We do it through data collection, the instruments we use, the procedures we use. We look at the confounding factors, which are our extraneous variables. And then we look at internal and external validity. Internal validity looks at the things that threaten the accuracy of the findings. They threaten your ability to say, did the independent variable make the difference? Was it my treatment that really affected the response, or was it something else? The first one of the internal validity factors we have to look at is history. There are historical events outside the control of the study that influence participants' responses. That they influence the dependent variable. Examples: the hospital changes equipment in the middle of the study, or 9/11 attack, or the tsunami. Both influence people's feelings, their beliefs, and their values. The second threat to internal validity is called maturation. It is the change in the dependent variable because of the passage of time. That can happen a couple ways. First, the participants adapt to testing, that you don't get as big of a response. That can be habituation. They got used to it. The nausea from chemo. Yeah, the chemo's still causing them to get nauseous, but they've gotten used to it. They've learned how to deal with it. They don't see it as a big deal anymore. Or, as the child grows older, it has different cognitive abilities. It understands the world and responsibilities differently. All three of those have to do with maturation. The next threat is testing. Changes in the dependent variable that result because it is being measured or because of the measure itself. Okay. Perhaps giving a questionnaire raises the consciousness of the participants in terms of what's being studied. Hey, I never thought about that before. Maybe I better. And now the thinking about it is changing their response to it. Not your intervention, just the fact that you're asking about it. Another thing that has to do with testing is, does home monitoring for preterm labor work? Or is it just that they're getting a nurse's attention every day? Next, there's instrumentation. That's the reliability of the instrument and the measurement we're using. Were the instruments used correctly and consistently? At the end of the day, are the researchers more tired and less accurate with the way they use it? Those are all threats due to internal validity due to instrumentation. Mortality is the next one. That's the loss of subjects as the study goes on. We're not necessarily talking about death here, although in some studies you might be, but in most you aren't. You're talking about people dropping out. Maybe the people who drop out are significantly different than the people who stay in the results, in the study itself. So that affects the validity of your results. Maybe the people who drop out are the sickest ones. Finally, there's selection bias. Those who choose to participate may be significantly different from those who don't. There's groups of people who do not participate because they don't trust researchers. Well, don't you think their responses are important and we want to know about it, but they have chosen not to be in the study. And other people are like, oh yeah, study me, I want to be in your study. They want to be in every study in the world. Those are two very different groups of the general population. It's very important at this point to say, if a study has problems with internal validity, it will automatically have problems with external validity. That means if you've got one of these problems, whether it be history or instrumentation or maturity, you don't know what's causing the effect you're seeing in your study. You don't know if it's the study itself, the experiment itself that you're doing, or if it's something outside. It's just that the people got older. And if you don't know that, you cannot generalize your results to some other population. And that's external validity. External validity. Can the results be generalized to a larger population? Well, we've got multiple ways that we have threats to external validity. The first one is reactivity effects. Some people call that the Hawthorne effect. Changes occur because the subjects know they're being studied. That's it. They just know they're being studied, so they react differently. Now that bleeds over into the next one, which is social desirability. People will respond to studies and study questions based on what society thinks is the right answer. They may not be willing to tell you something that society says is deviant or illegal or perverse. Measurement effects. Just asking the question changes a person's perceptions and responses. It raises awareness and expectations. Novelty effects. The respondents know, hey, this research, they're looking at something that's new and important, so I'm really going to pay attention. I'm going to give it my best. Well, you know what? That's not an honest, random response. And then there's experimenter effects. And I personally think that this one's pretty darn important. People answer what they think the experimenter wants to hear. And also, there may be something with that experimenter's personality that either turns people off or excites them. And that influences their response. Okay, descriptive statistics. Your reading goes over descriptive statistics pretty well. What do? They describe. They describe the population and the characteristics. What they don't do is predict. They don't do cause and effect. Univariate statistics, it's one variable analysis. These are things like distribution, the frequency distribution, how many are there, and what are the percentages. These are your bar graphs. Studies of central tendency. That's your mean, your median, and your mode. Go back to your stats class and look at these. What's the difference between the two? Univariate statistics look at dispersion. That's range. What's your highest? What's your lowest value? It looks at variance. How much do responses vary? Is it that you've got it fairly well distributed evenly? Is there a nice bell curve? Do you have one person who is way off the scale and everybody else is lumped together? It's all of those it's looking at, and standard deviation comes into that as well. And the second thing is multivariate analysis, and that is looking at correlations. Looking at more than one statistic at a time, more than one variable at a time. How do they interrelate?